Hello, welcome to the answer key to our little short quiz. So a couple of things. First, notice that the document didn't really import correctly. I don't know what the deal is here, but like notice how these arrows got moved off of the graph. They're just kind of like, these arrows are just kind of hanging out in space there. So you'll have to excuse that. The document does not look its best. The names got cut off here, like this is supposed to be g of x, and this function is supposed to be h of x. The names kind of got cut off there. And also, if you hear any weird noises, that would be my puppy, Lady Stanley, who is here sitting by my side while I do this video. So let's get to it. First, we had to analyze this function g of x here, and to figure out the domain range and the increasing and decreasing intervals. So this looks like a quartic function. There's no discontinuities, so the domain is negative infinity to infinity. The function is smooth and continuous. The range here does look like that there's an absolute minimum value of -9, and all y values greater than -9, there is an x value that will produce that y value. So the range is all y values greater than or equal to -9. Looking right there, there's the absolute minimum y value, but looks like the y values, every y value greater than or equal to 9 is represented. Great. So now increasing, remember we're talking about if you're sort of on the graph, at a point on the graph, and you're moving sort of from left to right, sort of what are the y values doing? That's sort of the loose, sort of intuitive way to think about increasing, and you give that interval using the x values. So it looks like, if I change colors here, that the function is increasing from here, color that right there, on that interval, and then also on this interval right there. So that would be from -6 to 0, remember I'm using the x values of the coordinates, union the interval, then it picks back up at 5, and goes out to infinity. Now for decreasing, I'll color that in blue, and while the function's already colored blue, I'll just kind of trace over here, this part of the function's decreasing as you move down here, the function's also decreasing here. You can also think of this as that if you pick any point in a decreasing interval, the function should have negative slope. Those should kind of be, ideas should be synonymous, that the function's decreasing, that the slope at that particular point of the tangent line is negative. So that interval is going to be, I just gotta scoot up the paper here, that's going to be from -infinity to -6, union 0 to 5. Great, now let's look at this other function here, this h of x function. First of all, there are two infinite discontinuities. There are two vertical asymptotes. One is at x equals 5, and the other is at x equals -5. Those are the equations of the vertical asymptotes. So that means that 5 and -5 will not be in the domain of this function. So h of 5 is undefined. So the same goes for h of -5, because if I pick, say, an x value of 5, there's no point on the graph that has an x value of 5 for that point. Another way to think about this is if I had this equation and I tried to substitute in 5 for x, I would end up getting undefined. That's what's going on there. But I don't have the equation. I don't have the algebraic representation. I just got this graph. So my domain, it's going to be all real numbers except for 5 and -5. So I'm going to write that as an interval from -infinity to -5, union from -5 to 5, union from 5 to infinity. That's all real numbers, all x values, except I'm sort of skipping over -5 and 5. That's why I'm using those parentheses to close off those intervals on -5 and 5, not a square bracket. Range looks like all the y values are represented here. Range is -infinity to infinity. Zeros of the function, kind of hard to tell, but I think there's only one zero at x equals 0, it's the point 0, comma 0. So there's only one x-intercept. There's only 1, 0 for that function. Great. So now let's move on to this next problem here. So you can tell this is all jumbled because this table, this is for this next question over here, but again, this document just got all messed up when I imported this. So we're looking at this quadratic function, the quantity x minus 1 squared plus 2, that's f of x, on the interval 0 to 4. So the domain that we're looking at here is just 0 to 4. I mean, normally, quadratic function would have a domain of negative infinity to infinity, but we're just looking at sort of this closed domain. We're looking at the function just on that domain. So I only want to pick x values between 0 and 4 inclusive to make my table. And then I can just, either do out some mental math, grab my calculator to fill in this table. Just doing this real quick. And when we plot this, we're going to see part of a parabolic function. So we got 0, 3. We have 1, 2, 2, 3, 3, 6, and 4, 11 runs a little bit off the graph, and we're just looking at that part of the function. We're just looking at this parabola over that restricted domain from 0 to 4. So the range over this restricted domain looks like the absolute minimum y value is 2. It looks like the maximum y value is 11. And we get all y values. Y can be anything from 2 to 11. Look at that graph. Maximum and minimum of f of x. Well, the max value is y equals 11, and the minimum value is y equals 2. Excellent. So now moving on to what is the back of your worksheet. So this table for fx, this should go on the back. So let me just go to the next page here. Oh, I see what's happening here. I thought I was going to go to the next slide, but the program just sort of cut out my blank axes to sketch number 3. So I'll just do a real quick sketch next to us here. So we had to plot these points and then make an f of x number line and answer some questions. So it should have looked roughly like this. 0 at 2, 0, 0 at negative 4, 0. Mine's not going to look nearly as nice as yours. So the parabolic function looks something like that, and with the y-intercept at 0, negative 8. Excellent, then we had to answer some questions. Oh wait, first we had to draw an f of x number line. So on our f of x number line, we're going to put the locations of the zeros, negative 4 and 2. And remember, we're just going to put a plus or a minus, indicating whether the y values are positive or negative in that particular interval. So when x is greater than 2, the y values on the function are positive. When x is in between negative 4 and 2, the corresponding y values are negative. And when x is less than negative 4, corresponding y values are positive on the function. So that just gives us an idea of what's going on with the y values, with the output values. Great. Then we had some more questions here. We had to evaluate f of 2 and f of negative 4, which we could have used the table for. F of 2 is 0, f of negative 4 was also 0. And then we wanted to solve the equation f of x equals 7. So what x value can you input to the function so that the function outputs 7? Well, I know one of those x values is 3 from looking at the table. And then if I recognize this was a parabolic function and plotted some more points and continued the pattern here, I know this one's not on the table, but I do believe that x equals negative 5 would also be a solution if you plotted those points really neatly. Some people didn't include the x equals -5 solution because they thought that we were just looking at this function over the domain from -4 to 3, so that was fine because I forgot to put the caveat that the domain for the function, we wanted to look over the domain -infinity to infinity, and that f of x was indeed a quadratic function. I forgot to put those details in the problem, so if you just gave the solution x equals 3, that was totally fine. And then we had the bonus, creating an f of x number line for this function. So I want to drop a number line down here with the zeros of the function. So using the zero product property, most people figured out that -3 would be a 0, that 0 would be a 0, and that 1 would be a 0 of the function. And then I think you could have made a table of values, picking values in each of these intervals. So you could have picked one x value less than -3, one x value in between -3 and 0, one x value in between 0 and 1, and one x value greater than 1. Made a table, evaluated the function at all of those particular inputs, and then figured out if the outputs were positive or negative. Or you could have graphed this function. You know, some people just had their graphing calculators on them, graph the function, and the number line would end up looking like that. A lot of you got that one, which was great. So hopefully this helped. Sorry that the input of the worksheet was a little bit messy, but hopefully that makes sense, and that you use this to study, and I'll see you in class.